Hello everyone, welcome back to this amazing series. I hope you enjoy. So, last episode we got VAOs and VBOs running, and some of you should have seen a triangle or something on screen, and some of you should have not seen something on screen, and that's okay, because for those who didn't see anything on screen, we will fix that today. So, what are shaders? Well, shaders, to put it in one sentence, are just a program that's run on the GPU. That's literally all it is, and it's nothing more than that. So how do we write our own shaders, and are there different types of shaders? Well, yes, there's three primary types of shaders that I know of. There's geometry shader, which we won't talk about in this series that much. Maybe we will cover it a bit, but not that much. There's the fragment shader and vertex shader, which are very important. The fragment shader is, you can think of it as just dealing with color, and vertex shader dealing with positions. You don't need to know much about them, but essentially that's what it is. So let's get to writing one. We can write one by actually writing a string. So let's do that. Const char. Let's write one first. Vert is equal to empty string, and we will fill that string in a second. But before we fill that string in a second, I want to organize my code, which I suck at. And oh shit, I did not copy it properly, so let's do that. Before I can continue with writing the shader, I would like to mention that I changed this from unsigned int to GLU int, which stands for OpenGL unsigned int. That is because int unsigned int like this can change size, isn't always a unsigned int, and etc. And plus, it's more standardized to use GLU int when dealing with OpenGL elements or objects. So yeah, where was I? Oh yeah, writing a OpenGL vertex shader. How do we do that? And I'll talk about what a vertex shader is in the meantime. Well, we can first, every shader, no matter the type, has to start with hashtag version and then the version. Most people will use 330 and then type the core or profile. I'll explain what core is in a second, but I'll stick with a version a little bit higher than that, 440. No, 440, yeah. And core essentially means it's using the modern functions of OpenGL. And you don't have to put this, but it is more standardized again, and most devices support the modern ones, so why not? Whoops, I'm not used to this G stuff in Visual Studio, my bad. So, next step. What is the next step? Well, first of all, we have to take in this, remember from last episode, the layout, the stride. We can do that by creating actually a new line first, and then we can do layout locations equal to 0 in vec to a pos. So what is this doing? Essentially, it's saying create a layout. Location is at 0. This is the index or the location, and it's taking in a vector2 and then the name of that variable so we can, use it. Essentially, that's what it's doing. It's taking in this that we sent to the GPU and is going to use that by assigning it a variable. So let's create ourselves a new line character. And let's create the main function in GLSL. Every GLSL program needs to have a main function, just like C. As you may have noticed, this looks pretty similar to C. However, the difference in GLSL and C is that in C, main functions have a signature, like int main, int argc, char argv, or whatever. But in GLSL, the signature is a bit different. It's literally void main, making it a lot simpler, but also, yeah, that's pretty much it. Now that we created the position, we need to assign the coordinates to the current position of the pixel. We can do that by simply typing in GL, small letters, GL position is equal to vec for a pos.xy and then 0, 1. What is this? Well, essentially we're saying this is the current position, is equal to a vector 4. The 2D positions x, y are, well, what we are sending to the GPU. The z can stay 0 for now unless we add models, then we will change that. And the w, which I know you might be confused. Wait, we live in like a third dimension. Yes, we do, but the w can stay 1 for now. And the w essentially is the scale, and it's also used for some other things, but keep it at 1. If you put 0 here in the w, it's not going to show anything, but it needs to be 1. So let me quickly write a fragment shader, which is very similar to a vertex shader, except instead of outputting the position, it will output the color like mentioned earlier. There's only going to be like 4 or 5 changes we have to do. We have to change this from in to out, change the name to frag color, set the output variable to be t frag color, and it has to be a vec4 this time, the odd variable we're outputting. And let's set the color to, I don't know, orange or yellow. Why not yellow? We can do yellow. And keep in mind, this is very important, the version of the fragment and vertex shader have to remain same. So in this case, I'm using 440 core. They have to be 440 core for both. Otherwise, it will not work. Great. So we have shader for frag and vert. How do we actually use these shaders? Well, we can do that by creating a couple functions. So let's create a function called, we'll call it compile shader. We'll plop in the source, and we'll do gl enum type. Essentially, what we have to do is we have to create a ID for each shader, and that ID will of course start with 1, just like every object, and we have to bind that shader program. Not this does not have to be bind, but it does need to have an ID, because you can access the object by using that ID. We can do gl shader source ID 1 source, and last can be null. So essentially we're doing the shader, which is the ID, count, which is, well, we're only having one shader right now, so 1, const, which is the source, so we can just do source or reference to the source, and length, which is a deprecated element. We can just leave it at null. And finally we can do gl compile shader, and then we can plop in ID. And oh yeah, we have to return ID. Return ID. Next episode we will probably get around to adding some AR handling for the entire program and maybe organizing the code a little bit, but for now this will do. And finally, we can actually create the shader program itself. This, if you thought this was a shader, no, this is, well, it is. It's the individual shader. But what sets it apart from the program is that the program is a collection of the shaders, so vertex and fragment together having one ID, and shader is a individual one, in this case vertex or fragment. This is very useful for a number of reasons, and like I mentioned earlier, so you can access individual elements. So now we can do, or doing operations, we can do create shader. Let's plop in const char vert and const char frag, and that's it. Let's create this function. So we need to return a program ID, so let's create one. It's equal to gl create program. This function has no parameters, so we can leave it a null. And why is this throwing me an error? I think I misspelled this. Oh, it's not that. Yeah, I misspelled it. Yeah, it has to be capital L. My bad. So change this from lowercase l to capital L. And finally, we can assign the glu int vert is equal to compile shader vert and gl vertex. Is it gl vertex? I think it's GL vertex, right? Should be. Yeah, it is. So we're basically calling our function to give us a new ID for our vertex shader and create it. And we also have to remember to do the same for the F. Let's change it to F and V since these are already taken by the parameters. GL fragment shader. And I think that's it for the main shader creation. Now all we have to do is GL attach. I can't type today, my bad. GL attach shader, and then we just plop in the program ID. And we just put the verter frag. Now this will just group up the shaders with the program, or shader program with the shaders. This is a very important step, so we can leave a comment called group up, and we can do the same for fragment frag. And one more function call we have to do, GL link program. No, it's program ID. Program ID. And that's it. We have a program. And now all that's left to do is return this. Return program ID. Yippee! We have a shader program. Now let's actually call this function that we just wrote. This one, create shader. We can do GLUint shader is equal to create shader. We put in the vert and frag as the source code of the vertex and fragment shader. And that's it. We have a shader. Now how do we actually use the shader? We can use it by calling GLUse program shader. You can think of this sort of like binding it, like we bind this, but instead of binding it, we're setting it to be the current shader that we're using. And I think that should be it. But we have to change this to F and V to use these variables, not the string. And I think that's it. So let's run the code, and we should be getting a colored triangle right now. Yikes. Okay, let me fix this. Has to be frag. My bad, my bad, my bad. And there we have it. We have a triangle that's yellow this episode. If you didn't see anything last episode, you should be seeing now if you follow the code correctly. You can change the color too. Since we have here yellow, the parameters are RGBA, so red, green, blue. We can leave a comment. Nah, we won't. I'll leave it here. Red, green, blue, alpha. Alpha just meaning the transparency of it. We can change it to maybe, I don't know, purple. So we have to decrease the green. Just make it blue and red. There we have, it's more pink, but purple too. You get the point. So that's it. Hope this video was something. Hope it taught you something. And next episode we'll get to organizing our code, restructuring, and getting it ready for actual Project Zomboid stuff. Hope you enjoyed the video. See you next time. Bye.